Welcome to the Data Future channel. This is Shekhar and I am a data scientist. So in this particular session, we are going to develop a machine learning model by using a different natural language processing technique and a machine learning algorithm to predict the sentiment of the review given by the customer. So what is exactly is the sentiment? So sentiment is the customer is talking about the product, whether it is good or bad, or his perspective is positive or negative about the product, or it may be a neutral one. So that we are going to predict. This is called as the sentiment analysis. So let's get started. So first we have to import all the required libraries here. So I'm importing in the first session, that is pandas, numpy, matplotlib, and seaborn. Out of that, pandas and numpy are used for the data manipulation, and matplotlib and seaborn are used for the data visualization. Then after that, I'm importing a few more packages. These packages I am using for the text pre-processing. That is called as the word embedding, so converting the text into the vectors actually. Then here I'm importing the stop words and the portrait stemmer from the MLTK libraries, so that I can pre-process the data, removing the stop words and for this stemming and lemmatization. Okay. Here I'm importing the word cloud to visualize the frequency of the word, then the string and what it is. It's the rejects. Regex. So regex is basically used for the again the text data cleaning and the preprocessing. Okay. Next, I am importing the trend test split for the splitting the data into training and testing. Label encoder to convert the categories into numbers. Then the evaluation matrix for evaluate the model. Then the linear model, logistic regression, and the multinomial naive-Bayes algorithms I am using to build the models. Okay. So this is about the these packages. The next thing is we have to load the data. So load the data means we have to read the data from the CSV file. So pd dot read underscore CSV. I'm reading the data and I'm trying to display the first five rows. Okay, so you can see here the columns, the ID, product ID, username, user ID, profile name, usefulness, the score is there, score, summary, and the text. So out of that, we are going to consider score and the text. The score is the rating given by the customer, and the text is the feedback given by the customer on that particular product. That is the review. Then we'll check the number of rows and columns. There are 67,000 rows and 11 columns are there. We can display the list of columns by using a data dot columns like this. And then I'm selecting, creating a new data frame, selecting our specific columns, that is text and the score, which is useful for our processing. Okay, now this data is ready. Now we can say how many score is given by the customer based out of 5. So here you can see uh, the based on these numbers, the three score is given for 15,000 customers. Score rating is given by 15,000, 1, 5, and 2, like this. So these scores are given, and based on that score, we have to see whether the customer has given a positive or negative feedback. So from itself, the score is 1 and 2 means it's a negative one. The 3 and 4 means it's a positive feedback, and 3 means it's a neutral one. Okay. So we will we will plot the bar graph for this. So you can see the most number of reviews are for 3 and 4 ratings, and the least one is for 2 ratings. Okay, that's fine. So here we can consider data is balanced one for all the categories, right? Then we have to check whether there is any missing values present in the data. And for that, yes, I can say by using this dot is null dot sum can be used. Then I can check um, this whether there is any duplicate records are present in the data. So dot duplicated function I am using. So here you can see that 9,354 rows are duplicate one. So there is a no point in processing the data with this duplicate. So it's a better way to um, just remove or drop duplicates. So that is the best option to drop the duplicate. So data one dot duplicate. What we can do? Yes, we have created new data frame. Now check the shape of this. 57,000 records are available with us. Now one more time, I'm checking the value count for each store. Now you can see, yes, data is quite uh, balanced one here. Okay, fine. Now what I'm going to do, I'm converting data into a positive, negative, and negative and neutral reviews. So for that, I'm writing a function here which will map if the score is lesser than 3, it will return the negative value. Negative review, is it exactly equal to 3 is a neutral one. And other than this, it will be a positive. So map review, we are using the function so that the 4 and 5 will be positive, 3 is neutral, and 1 and 2 is negative. Okay. So for this, I am creating one more column, that is the review, and I applying this function to the score column where dot apply lambda x semicolon map underscore review is the function and applying to the x. So what will happen? You can see the new column is created which can give you the exactly these things, the mapping of score to review. Okay, so here we can say dot review. When I do the value counts here, you can see there are three categories only: positive, negative, and neutral. Okay, yes. Now next thing is what we have to do. So we have to pre-process the text data. Okay, text data cleaning and pre-processing we have to do. So date, text uh, cleaning, cleaning and pre-processing. Text cleaning and pre-processing. So here we have to import the NLTK. So we have to import the stop words and we have to display the stop words. Now here I'm creating a, a list of stop words. But what is happening? We whenever there is a no or not is there, in that case it is considered as the stop words. But to understand the negative feedback, we have to consider that words actually. Okay, negative words. So what we are doing, the negative stop words we are removing from the total stop words here, and then we are getting the final stop words. Okay, here. So what you will get? So you will get this thing. Okay, so you will get these are the stop words here, right? So yes. So next one is uh, stammer. So we have to convert the word, that token, into um, uh, its original form, or uh, into its stem. Okay, so means it's a original form we have to convert. So for that we are using a Fortress stammer here. We have to remove the HTML tags if there is any. We have to remove the punctuations here. Then we have to remove the numbers, and we have to remove the mm, multiple white spaces. Okay. Now, what I am doing, I am writing a function which is the text preprocessing. It is called as a text preprocessor and providing a review. So what I am doing here, I am reviewing the HTML tags here by using this. Then I am removing the punctuations here. You can see here removing the punctuations. Okay. Then here I'm removing the digits. Here I'm converting into a lowercase. Then I'm replacing the multiple white spaces with the single space. And here I'm removing the stop words also. And finally, I'm joining uh, this thing by using a stemmer. Okay, stem form of it is the original form of that particular word, and returning the review. So you can see I'm having a sample text text here, and I'm running this function for this text. You can see this is the clean text you are getting, removing everything, right? So yes. Now next thing is we have to use um, uh, we have to use the yes. So here we have to use we have to generate the word cloud, and for that we are using this particular function. Okay. So here what I say, it's a word cloud. So word cloud is nothing but the visualization of the most frequently occurring words in the data. Okay, so we'll see that. So here, um, what we have done, so we have written a function that is the generate a word cloud and providing the argument at the text. So stop words is the state of stop words. Then word cloud is equal to word cloud stop words. Background color is white, and word count dot generate a text. So here it will it this is the figure settings. Okay, and finally with this function, when you are providing the text, it will generate the word cloud. Okay. Now I'm separating the reviews. So first one, I'm separating the positive review by data2 dot log, and I'm using this condition, and I'm using dot text. Okay, and text is equal to dot join um, the review for review in the pos dot uh, is as type string. Okay, and finally what it will do, so it will generate a word cloud for the positive reviews. Positive review word cloud. So you can see that, so it will take certain time because the data is huge in this case. But yes, here you can see a nice word cloud where you can see these are the words you can see for in the positive positive reviews. The same thing we are going to apply for the negative review. Yes, here is the negative review a negative review word cloud. Okay, negative review word cloud. So I'm running the same thing, only changing this negative data frame. So when you run this, you will get the same thing, and we are doing it same for the neutral review. Neutral uh, word cloud. Okay, that's all. So we are parallel running this because it will take some time here. Okay, yes. So you can see for negative review, you can see there is a product, flavor, copy, taste, one, even, taste. So many words are there. The same thing is will happen here for the neutral one. So you are getting these things, um, this word cloud for positive, negative, and neutral. Yes. So for neutral, it's you can see that. Okay. Yes. So this workout will help you to identify what kind of the most frequently occurring word in that particular text for positive, negative, and neutral. So here we are splitting the data into X, X and Y. So where the Y is review and the X is the text. So we are target variable is Y actually. So we are splitting the data into training and testing, training and testing. Okay, so here is a text and here is the review. So we are using a train test split. So X train, X test, Y train, Y test, and using a 20% data for the trend, testing, 80% for training, and statify is equal to Y. So when you run this, now you can check the shape of the data. This is the train data and this is the test data. Okay, now we have to convert the data into using a word embedding technique. Okay, so word embedding technique means we are using a count vectorizer. This is the one method with which we can convert the text into its array. Okay, it's kind of numbers we can say. And second one is TF IDF vectorizer. These are the two methods which are used for the word embedding. What you can say, it's a word embedding. Okay, run this. Yeah. Okay. So now what I'm doing, the bag of words vectorizer is equal to count vectorizer. Maximum features is 10,000, and we are fitting it to the extreme. Now what we have to do, this extrain is equal to bow vectorizer dot transform extrain and xtest bow vectorizer dot transform xtest. Okay, so we are having data is ready. Now you can see we have converted into a vectors. Now if you want to see the one vector of it, now the all the text is converted into its vector. Now you can see there is a matrix. So yes, the data is yes, the whenever we are having a data, that data is basically is the huge. So because of that, it will take a lot of time to convert into a matrix. Okay, now you can see that here is the sparse matrix is there. Okay, and NP numpy array is there, right? Okay, the same thing we can do it by for the TF-IDF vectorizer. Both are doing the same thing, but we are checking for these two different cases. Okay, what are the results? Okay, so this is the same thing. Then we have to use the encoding that is called label encoder. So why this label encoder is required? Because we have to convert that our reviews, that is positive, negative, and neutral, into one, two, three, or 0, 1, 2, something like that. Okay. So let the run this because it will taking some time. Yes. Now we are importing a label encoder and white train and white test. We are transforming it into uh, this these numbers like positive, negative, and neutral. And later on, we can see yes, you can see the three classes here. The 0 means negative, 1 means neutral, and 2 means positive. It's kind of alphabetical order it will map. Okay. Now I have written one more function to train the model actually, to train and evaluate the model. Okay. So training and evaluation, training and model training. We'll say the model training and evaluation. Okay. So what exactly it is doing? So train and eval this model. So we are providing the model, train X, train Y, train test X, test Y. So model dot fit train X, train Y prediction trains and Y prediction test. We are using this thing here. And finally, we are printing what is the accuracy Y train, Y prediction train, and Y test. So we are checking two accuracies. One is training accuracy and another one is the testing. So that based on this, we can understand whether there is a model is overfitting or not. So model overfitting is basically based on this thing. Uh, if the both the training and testing accuracy, if training accuracy is more and testing accuracy is less, then it can say we can say it's a overfitting case. So here we are using a logistic regression first, regression, and what it we are doing here, we are selecting the hyperparameter that is C, and we are checking the model for each and every C, that C value. Okay, and we are choosing the best C value here. Okay, so we are checking C in the C, and then we are using this model logistic regression, and we are putting the model into this particular function so that it can give you the results. Okay, so you can check. Yes, obviously it will take certain time because this is uh, this is checking for each and every possible value of C. It will evaluate the uh, yes. So the first accuracy we got is 67 and 65%. The train is 67, test is 65. This should be closer to one another. So this is fine. And again, here we are using the count vectorizer. So the model logistic regression with hyperparameters and hyperparameters and count count vectorizer. Okay, count vectorizer. Okay, so both ways we are using here. So this is still running because yes, obviously for each and every case it will calculate the training and testing accuracy. So second iteration is over. Now three iterations are left now. Yes, it will take certain time Meanwhile, we can write here some text here so that you can understand what will going to happen in the next. So here we are using a naive Bayes model with hyperparameters. Again, alpha is the hyperparameters, and here we are using a count vectorizer as this. Then same thing we have to carry out for uh, the TF IDF, which is the word embedding technique. Here you can see again logistic regression, but here is the TF-IDI vectorizer. Okay, yes. Now two more iterations are also there, but yes, we have to wait. Mhm. Meanwhile, I will copy this thing TF-IDF vectorizer so that yes, here it is. TF-IDF vectorizer. Okay, fine. Now, okay, one, two, three. Still, there are two iterations are left for this particular case. So from this, you will get the idea how we can carry out this, but it will require certain time. Okay. So meanwhile, what we'll do? So we can write here what naive-Bayes model with hyperparameters and TF-IDF vectorizer we have to use here. Okay, TF-IDF, TF-IDF vectorizer, TF-IDF vectorizer. So we have run this. Okay, meanwhile, so it is taking too much time. So only three iterations are over, but it will take a lot of time. Okay, better way we will check only these two one. So I'll run this also, and we will skip for the TF IDF vectorizer, right? Yes, four is over. One, two, three, four. Now one more iteration is remaining. So for this particular case, you can see a lot of overfitting. So why it is 83 and 67? So a lot of difference is here. Here is again quite overfitting. Here it is matching actually the improved some accuracy 73 and 69. That's fine. I think this is the best model out of this. Rest of all having these things. Now five are over. I think no, one more is remaining. It's one, two, three, four, and 10. So 10 is again it may be a problem of overfitting. You can see. Okay. Okay, fine. You got this accuracies here for this. Again, you can run it for here for TF IDF, but the best model we will get here for TF IDF. So you can see for Naive we are having these models. We'll check for the logistic regression with TF IDF vectorizer. Here you got this accuracy. Yes, second one, it's quite good. Third one, okay, 70, 68. Oh, great. Then two iterations are pending here. So for 1 and 10. Okay, it is taking too much time. But yes, yes, fine. It's a 77 and 70. It's a good accuracy you can get here. So I'm skipping this because it is taking too much time. So I'm considering is the base model is logistic regression with TF IDF. Okay, C1 is equal to 1, maximum iteration 500, and I'm creating a best model here. Then I will predict um, this train and test one, and then again checking the accuracy here. So yes, let it run and check the accuracy training and testing. And we will finalize the model which is logistic regression with C is equal to 1 and the vectorizer TF IDF vectorizer, right? And then we will do the model prediction uh, for a particular review. Okay, so let it run for few seconds and then we'll check. Okay, it will take certain time. No issues. We have to wait. It required a lot of patience. Okay, it's taking too much time, but yes, it will run and it gives you the correct accuracy. Yes, yes, yes. So we got this accuracy. Okay, fine. No need to worry about this because already we got this accuracy here also. Okay, fine. Your model is great. Then we will put this confusion matrix. You can see this is the confusion matrix here, and we will save the model. We will skip this term, but we are going to predict whether the positive or negative or neutral. So for that, I have created one function that is review x text processor. So we have to convert that x, then TF-ID is vectorizer. I need to transform the x, and later on y is equal to integer of model b, best model dot product x reshape 1 minus 1, and then labels equal to y, labels of y. Okay, you can see now I'm putting a two reviews. One is this cheap packet is very tasty. I highly recommend it. Okay, you can see it's a positive review. Oh, great. Then this product is a waste of money. Don't buy this. Okay, so like this, you can create your own model, build your more model for the text analysis. So this is the nice session on the text data processing and build the model on top of that. So if you have it, if you like this video, then subscribe my channel and do comment if you have any queries on this. Okay, thank